Now let us look at this question carefully. It's a redox titration, and we are being told that you are provided with solution A, which is acidified potassium manganate 7, solution B containing 23.5 grams of ammonium iron 2 sulfate in mass per liter. Then we are told that we are required to standardize the potassium manganate 7 solution A using ammonium iron 2 sulfate solution B. So when you look at the procedure, we have the average volume of solution A that was put in the burette, and we pipetted solution B, which was ammonium iron 2 sulfate solution. Now on to the first question, we are being asked to determine the average volume of solution A. So when you do the experiment, we can have a pseudo value of 20.0 as the average volume for solution A. And then part B, we are asked to calculate the concentration of ammonium iron 2 sulfate solution B in moles per liter. I want you to remember that up there we were given the mass per liter of ammonium iron 2 sulfate, and we've been given the relative formula mass of ammonium iron 2 sulfate. Therefore, for us to calculate the concentration in moles per liter, we'll just take the mass per liter divided by the relative formula mass, which will give us 0.0599 moles per liter. Then on part C, we have been told to calculate the number of moles of iron 2 sulfate in 25 cubic centimeter solution. Remember that in part B, we've calculated the concentration, and do not forget that we pipetted 25 cubic centimeter solution of B. It therefore means that for us to calculate the moles of iron 2 ions, we'll just take the molarity times the volume divided by 1000, which will give us 0.0015 moles. And on the last question, we've been asked using the ionic equation for the reaction between manganate 7 ion, calculate the concentration of manganate 7 ions in solution A in moles per liter. When I started, I mentioned that this one is a redox type of titration, which involves reduction and oxidation. So manganate 7 ions undergoes reduction to form manganate 2 ions, and iron 2 ions undergoes oxidation to form iron 3 ions. But do not forget that we pipetted 25 cubic centimeter of iron 2 ion, and the number of moles in 25 was 0.0015 moles. And on the average volumes in the burette, we got the volume of manganate 7 ions. Therefore, using the balanced equation, the mole ratio for manganate 7 to iron 2 ion is 1:5. And therefore, using the mole ratio, we can get moles of manganate 7 ion. But do not forget that it is in 20 cubic centimeter. How about in 1000 cubic centimeters? That is why we will end up having 0.015 moles per liter of manganate 7 ion. Thank you. See you in the next video.